Okay, this one again, I'm going to try to keep mercifully short. Okay, the rock cycle. We'll tie it all up. Okay, we'll tie up these three different rock types. Okay, so here you go. The rock cycle is simply the process by which the materials that make up the Earth's crust and lithosphere are cycled through the process of plate tectonics, essentially. So basically, what happens is you have material that's originally volcanic rock material or igneous rock material that gets eroded and turns into sedimentary rocks, and then gets put under pressure, turned into a metamorphic rock, and eventually gets so hot it melts and becomes magma again, and then that whole process starts all over again. So there's this cyclical behavior, the cycling of matter through plate tectonics and erosion, and we call that the rock cycle. It's kind of cool. All right, so step one, magma cools either as magma or lava, cools and solidifies, forming igneous rock. All right, so I have igneous rock that now gets exposed to the elements, to weather. So the second thing that happens is these igneous rocks undergo weathering. So basically, remember ice wedging and the action of plants and chemical weathering, turns the some of the minerals into clay, which loosens up the other things. And then what happens is those get transported downhill by wind and weather, by wind and water. And then when that wind or water slows down, deposition occurs, which tends to sort out the different size particles. And then they get compressed and lithified and become sedimentary rocks. And so that's the second step in it, the transition from igneous rock to sedimentary rock, which again involves weathering, transportation, deposition, and lithification. Then heat and pressure cause it to turn into a metamorphic rock. So it can either just be heat itself or it can be heat and pressure. But the end result is what was a sedimentary rock is now becoming igneous. Now it's worth noting, you know what? You can have erosion of sedimentary rocks. You can have erosion and transportation of metamorphic rocks. You can have metamorphosis of igneous rocks. You can have metamorphosis of metamorphic rocks. Okay, so it's not like a very simple loop pattern, but the bottom line is eventually whatever rock we have will experience heat and pressure and undergo metamorphosis. And as that heat and pressure continues, eventually that rock will then melt and join the magma. So there's a rock that's here under enough heat and pressure, it melts and it becomes part of this magma body here. This rock here is melting and becoming part of this magma body. So here, this rock material here and this rock material here end up melting and becoming this magma here, which then erupts here, and the cycle starts all over again. Now, it's worth noting then that the magma that comes out here is different from the magma that we started with. So I had one particular chemical composition, I wrote it, and guess what? I sorted out, like the clay minerals got carried away here. So then the sandstones were here. So already I got this difference. Now I'm adding like carbonate material from reefs. I'm adding water, right? And I'm bringing it down here and I'm melting it. Now I'm combining this with what was here. So basically, the new magma, although when the cycle is complete, I'm not back to where I started, other than that I'm back to igneous rock, but this igneous rock is going to have a different chemical signature to it. It's going to have different minerals present in different proportions because it's a different chemistry to that magma. But the cycle is constant. This has been going on since the world has cooled down enough to have solid rocks at the crust. Now, it's worth noting, though, that this is a good time to go back and talk about the carbon cycle that we started talking about way back at the very beginning of the year. Okay, so here's what we find. Atmospheric carbon dioxide diffuses into the ocean. Now that it's in the ocean, basically it becomes carbonic acid. We won't worry about that. But then these aquatic organisms take that carbon dioxide and use it to make shells or tests. So, little foram floating in the water, or coral, or shells, or nautiluses. Okay, these things all take in this stuff and this carbon and turn it calcium carbonate. Okay, now when these organisms die, the shells that they made fall to the bottom of the ocean, and under pressure, they basically become cemented down, compacted and cemented down. They become limestone. Well, now through the action of plate tectonics, the limestone on the seafloor will eventually get subducted. And when it gets subducted, when that limestone melts, that calcium carbonate, which has carbon and oxygen in it, will end up melting and going back into this magma. And what was limestone will basically be dissolved. And the calcium carbonate, guess what? The carbon and oxygen go back into being carbon dioxide. So now you have carbon dioxide present in lava. So we find more carbon dioxide in lavas with more limestone because it's adding a lot of carbon and oxygen to them. And then when the volcanic eruption occurs, that carbon goes back in the atmosphere. So we call this the slow carbon cycle because this process takes millions to hundreds of millions of years to take place. But it is a cycle. The carbon started in the atmosphere, went into the water, went into the shells, went into the limestone went into the ground, it melted it and came back out. So it's this long, slow carbon cycle. And here's a graphic of it. So here I have, so here, boom, outgassing of carbon dioxide. The carbon dioxide ends up coming into the water. When it gets in the water, there are organisms that are going to turn it into calcium carbonate. Now that calcium carbonate is going to, here we go, shell major area of limestone deposition. And then these limestones end up getting subducted and then they melt, the carbonate rock melts. And then what happens is the carbon dioxide comes back into this and it goes back into the air as carbon dioxide. I think that's it. Okay, thanks for watching. I told you to be short.